Confidence interval is our last topic in normal distribution that we are going to cover today. So, this is an interval within which an unknown population parameter lie with a given degree of confidence. Confidence means we are sure that that is a probability. The two extreme values of the interval are called confidence limits, i.e. we have the upper limit and then the lower limit. So this is how we give our confidence interval. It should be bounded because the value can be that or the upper. It should be bounded. Width of the interval is the difference between the upper and the lower limit, i.e. to get the width of the interval, you get the upper limit minus the lower limit. Note, at this level where we are going to consider the only conditions when we know the standard deviation. That's what we are going to consider at this level. And when we use that, always the sample we are using A should be greater or equal to 30. Why? In real life, by the way, if you have a sample below 30, in most cases you won't be able to find the standard deviation or sigma. That's why we limit our sample to be greater or equal to 30. Okay. This n is a number, is the sample number. So the parameter that a true population parameter will lie between a steady interval is noted by 1 minus alpha, where alpha is the parameter, given as 1 minus alpha times 100, the percentage. In establishing the interval, we find the z value corresponding to alpha over 2, i.e. z alpha over 2, which is symmetric about the mean as shown below. So, if I say that my confidence, if I say it's going to be the limits I want to find there from here up to here, I say 1 minus alpha over 2. If this is my confidence now interval, it means that now, remember that it is now a standard curve, and we say the whole area above this is 1. Above from here up to here is below the curve. The area below the curve is 1. So, if this is 1 minus alpha, it implies that to get to 1, this remaining from here up to here is 1 minus alpha. Then because the whole curve and area of the other curve, the whole area under this curve is 1, it means that these two are equal to alpha. And if you say that this and this are symmetrical, why? Because I'm in here in a standardized variable is going to be 0. So this is symmetrical, this is meaning if the remaining thing is alpha, so when we add to this, we get 1. Then this should be alpha over 2, and this should be alpha over 2. These two should be equal. Note, alpha over 2 plus alpha over 2 is alpha. So, when we add this plus this, we get alpha, and then add it to this, we shall get our 1, which is the total area under a normal curve. This is the statement that it means as simple as that. So that this one is going to cut this z. At mu here. Now the standard value of a sample mean is given by this. I think remember that from our previous lessons. This is given by z. This is now shows the sample mean minus this over standard deviation, then over square root of n, which you can just multiply this there. Since alpha, z alpha over 2 is metric about mean, the confidence interval or the limit of mu are given by. Now, because metric, this is true. Now, our z from here is given by this. Now, we want to get the confidence interval for mean mu. This mean mu. So now, if I cross multiply this, I get this. I cross multiply also this, I get this. I want to make mu the sum, but since it has a negative, so I first multiply it by negative, so that this one becomes a positive. But instead of multiplying by negative in inequality signs, the inequality signs change. That's why it's that this one is changing. When multiply it by negative, you get a positive. This one changes to this. This one now becomes negative. This one becomes positive. This one changes to this. And now this one is positive times negative. We get that. And so if you make me the sum with it, this one will take it will be positive, and we'll take this side, it will be a positive. Now, this is now the confidence interval, or the confidence limits for mean mu. This is called the lower limit, and this is called the upper limit. So, the confidence interval is given by x plus or minus, this plus or minus, sorry, I forgot this is plus x bar there. The plus or minus this plus or minus there, and this. So this plus or minus, when I bring it here, you see that's what it's going to be. Now note that sigma over root n is what we call the standard error of mean. Sigma over root n. So that's how we have that. Now the next question we are going to see, when they ask you for the confidence interval, get your sample mean, put in the value at alpha over 2, get the standard deviation over the sample, root of the sample they are giving you. Then you will be able to set the limit. Or else the limit should be crossed. If they give you the interval, should be crossed like that. So the next lesson we are going to see how do we handle the limits, how do we read them from the table. Then you see how questions are going to be like. So that's it, members. See you in the next lesson.